California Polytechnic State University is located in San Luis Obispo, California, on the scenic Central Coast. Nestled between rolling hills, the campus includes a portion of Brizolara Creek, which feeds into the Pacific Ocean. Our project is focused on the areas surrounding this creek, which primarily consist of parking lots. These impermeable lots slope sharply down, leading runoff directly into the creek. At Cal Poly, high levels of precipitation have caused issues with flash flooding and excessive discharge into the creek. Precipitation also creates runoff that picks up pollutants from the parking lots and nearby agricultural areas, flushing it straight into the creek. Recent water quality sampling has revealed elevated levels of nitrates, metals, and oil and grease within Brizolara. Cal Poly's 2035 master plan details the upcoming renovations and constructions for the campus. On our selected site, Cal Poly plans to build new housing units to increase the student population on campus. This will restrict already limited student commuter parking and will increase foot traffic in a fragile ecological zone. In Slow Your Flow, we address three main goals that align with Cal Poly's master plan: prepare for future student populations, reduce creek pollution, and encourage the use of valuable student-centric spaces. We propose the addition of a new parking structure featuring a green roof and adequate parking spots for students and staff. This will be placed in the furthermost parking lot, leaving the closer lots empty for future development. By reducing the parking footprint and including natural rainwater filtration, we ensure that commuter students have adequate parking in a more sustainable manner. Across the existing parking lots, circulation is not ideal. Both the Arrow Hangar, a student-led project shop, and the Arboretum are located nearby, but travel is inhibited by the prioritization of cars, disconnected bike/pedestrian infrastructure, and the steepness of the hill. The extension of current sidewalks, as well as a winding path at a lower slope for bikers and walkers, will connect valuable student sites and encourage students to enjoy the spaces. To address creek pollution, we plan to expand the current riparian buffer and strategically place bioswales with native plants to combat runoff and erosion. This riparian buffer can be included in the master plan's Creekside Village as a student-oriented space for studying and other leisure activities. Including educational aspects such as plant identification signs will also encourage students to learn more about this ecological area. Our proposed changes reduce total runoff into the creek by 9%, along with increasing the utilization of valuable student spaces. This design is an example of how green infrastructure solutions can be integrated into broader campus plans.